Okay, so we're going to look at lesson 3 today, and we're going to start to look at some new vocabulary. Although we've sort of looked at what these look like on a Venn diagram before, we haven't necessarily looked at the precise language that we use within set theory to talk about these things. Okay, so the first thing that I want to discuss is something called the union. The union of two sets is when we join two sets together. Okay, so the joining or merging of two sets. Okay, so for example, if, oh, and the symbol, by the way, that we use is the letter U. It's kind of a stretched out U. So we would say A union B, or we would say the word or, actually, A or B, okay? And so an example is, let's say A equals the elements 1, 2, 3, and B is the elements 3, 4, 5, okay? Then A union B would be, we're going to merge these together. We're going to join all of their elements together, but when we join them together, we don't count the same element twice. So 3 is in both of them. We're not going to double count that. So the elements in both would be 1, 2, 3, 4, and 5. Okay, so that's the union of two sets. Okay, the intersection is two sets is the overlap of two sets. Okay, and we use the same symbol but upside down. So A intersection B, or we use the word and. A and B. Okay, and using the same subsets, if A is 1, 2, 3, and B is 3, 4, 5, then A intersection B would be, what's the overlap between these two sets? It's just the element 3. That's the only one that's in both. Okay. The last one that I want to talk about is minus. Okay. And basically what this means is only. Okay, so if we're talking about A minus B, we would be looking at elements that are in A but not in B. Okay, so we would say it out loud as A minus B, and it's elements in A but not in B. Okay, and the notation that we use is like a backslash. Whoops, not B minus A minus B. Okay, so if I'm talking about A minus B, using the same sets above, right? So if I'm looking at A, that's 1, 2, 3, and I take out anything that's in B, well, the element that's in B is 3, because B is 3, 4, 5, right? So A minus B is 1 and 2. Okay, and you can think of it as like only A, right? So think only A. That's one way of thinking of it. Okay, so just to sort of summarize what we've seen so far, we're going to use this example here to fill out this chart. Okay, to talk about some of the things that we've seen so far. So our universal set are the elements 1, 2, 3, 4, 5. A is the subset 1, 3, 5. B is the subset 2, 4. and C is the subset 1 and 5. Okay, and I wrote the word symbol twice, sorry, so this should be the vocabulary word. Okay, so these symbols, and actually not to confuse it with this one, they should perhaps be farther apart, is what we use to denote a set. Okay, and it's a collection of elements. Okay, so any of these examples would be a set. I'll use the universal set. 1, 2, 3, 4, and 5. Okay, this symbol over here is the notation for a subset. Okay, and it's when all elements in one set are in another set. Okay, so if, for example, we're talking about the fact here, let's say C is a subset of A because 1 and 5 are in A. So I'll say that C is a subset of A, right? So what does that mean? All elements in C are in A. Okay, this symbol over here is the empty set. And it's a set that has no elements. Okay, and also, by the way, we can use this as well to show that something's empty, right? Just a set of curly brackets close together with nothing in them. So we could define an empty set. For example, I could define set D, which are let's say multiples of 50, right? And if my universal set is just 1, 2, 3, 4, 5, well, there's no multiples of 50 within my universal set. So we would say that set D is empty. Okay? Complement, A complement. Okay? So A complement is everything in the universal set not in A. Okay, or you could think of it as not A, right? In the universal set, but not in A. And A complement, if A is 1, 3, 5, then the elements in U but not in A would be 2 and 4. So A complement equals 2 and 4. Okay, and then we've got this backslash, which is minus. Okay, so this means in one set, but not another. Okay, so if, for example, let's say I did A minus C. Right, so if I take set A, which is 1, 3, 5, and I subtract set C. I take out the 1 and the 5. All I'm left with is the 3. Okay, this symbol over here is union. Okay, and it's all of the elements in both sets. Right? And the other thing that you want to think about is the word or. Okay? So if, for example, I did, I don't know, B union C. If I joined those two sets together, I would get 1, 2, 4, and 5. Okay, and then the last one is the intersection. Okay, and it's the common elements to both sets. Right, or the overlap. right? So you want to think of the word and here. Okay, so for example, I did, let's say I did A union C. Okay, the common elements, not A union C, my bad, I wrote the right thing, but I said the wrong thing. A intersection C would be what's common to A and C, it would be 1 and 5. Those are the elements that they both have. If I looked, let's say, at the intersection of A and B, let's look at that. Okay, so A and B actually have no common elements. There's nothing shared between those. So we would say that the intersection is empty. Okay. All right. So that's just a nice little summary chart that you may want to come back to that summarizes basically all of the vocab that we've looked so far and all of the symbols that go with it. Now what we're actually going to do is look at how some of this notation would correspond on a Venn diagram. Okay, so we're going to use this universal set, 1, 2, 3, 4, 5, 6, with two subsets, 1, 2, 3 is A, 3, 4, 5 is B, to talk about what these shaded regions mean. Okay, and we're going to do it with what would it look like using the correct set notation, how would we say it out loud, what would it mean, and then what elements are we talking about. Okay, so this shaded region right here, basically what we've done is we have joined these two subsets together. That's a union. Okay, so the set notation that we would use is A union B. And that's exactly how we would say it. A union B. Okay, what does it mean? It means A or B. You might want to say or both because that's sometimes a source of confusion, but it's A or B or the overlap or both, okay? And what elements are we talking about here in this scenario? 1, 2, 3, 4, and 5. Okay, the second one over here, all that's highlighted is the overlap of A and B. That would be the intersection of those two sets. A intersection B, and that's the way that we would say it as well. A intersection B, and this is the word and, right? It means A and B. Okay, so in this case, the element that we're talking about, there's only one of them, and it's the element 3. All right, this next one. So if you look at what's highlighted here, everything except for subset A is highlighted. And when that happens, we're talking about a complement. Okay, so this would be a complement. And the way we'd say it is exactly how I just did. A complement. Okay, what does it mean? Not A. Okay, so in this case, what elements are we talking about? We're talking about 4, 5, and 6. Okay, and then the one below it is exactly the same thing, but now we're talking about B complement instead. So not B. And here we've got three elements, 1, 2, and 6. Okay. And then the last one on this page, we only have part of A highlighted, and the part that's not highlighted is the part that's also in B. So B has been cut out. This is a minus situation. Okay, so this is A minus B. We've taken the set of A and we've subtracted out B. We've taken out the part that's also in B. A minus B. So what does this mean? It means only A. Okay, and the elements that are only in A are 1 and 2. Okay. And so now what I want to talk about, and we've kind of already intuitively discussed this because we've talked about solving problems already with Venn diagrams, is this fact that when we are talking about the number of elements in a union, okay, this right here, this formula, in A or B, it's equal to, this is the number of elements in A plus, this is the number of elements in B, but then what we have to do is we have to take away the overlap. Because if we don't take away the overlap, and there is overlap, we're going to be counting the overlap twice. Because we're counting it once for the elements in A and once for the elements in B, minus the number of elements in both A and B. Okay? And so we're going to look at what this looks like in a Venn diagram. And we've also kind of already talked about it when we talked about the fact that we had those examples from yesterday where we had more responses than we did people. Okay, so let's take a look at this Venn diagram here. Okay, so it looks like people were surveyed, 28 students were surveyed about who owns a cat or a dog. Okay, and if you look at what's going on here, there's 4 regions. There's only cat, only dog, right? So there's only cat, only dog, both, or neither. And if you add up all of those regions, you've got 6 plus 10 plus 8 plus 4, so that's 10, 20, 28. Right? And that should make sense because there's 28 people who were surveyed. Okay? So what this formula is telling us is the number of people in the union. Right? And in this case, the union is actually just 24 because we're not taking out these two. So we're just looking at the 6 plus the 10 plus the 8. So that's actually just 24. Okay? Right? So if I put it over here, this is 24 equals, well, the number of elements in the cats, how many people have cats? That's 16 altogether, because it's 6 plus 10. So 16 plus 10 plus 8 is 18, right? But then if we actually just added those two up, we would be counting those 10 twice, because we've counted the same person who owns both, once in the cat category and once in the dog category. So we have to subtract the overlap and subtract 10. And that's true, because 16 plus 10 is 34, minus 10 is 24. Okay? Now, if you have a Venn diagram in front of you, you're probably not going to use this formula because you can see very easily from the regions in the Venn diagram exactly what you have to count. Okay? But this formula does exist, and occasionally you might be given some information where you might need to use this formula because you might not have a Venn diagram, right? Or you might you might be missing parts of the Venn diagram that you need to know, and so the formula might come in handy. But the idea really, actually I should flip back to it for a sec, is that this piece, the elements in both cannot be counted twice. Okay, you have to subtract them once that they don't get over counted. All right. So let's do an example. This one's always fun because people always get excited over what counts as an implement. All right, the athletics department at a large high school offers 16 different sports that use a ball, B, and an implement, I, or both a ball and an implement. Okay, so an implement, by the way, is something that a player would use to play the sport. Like, for example, a racket or a bat or something like that. Okay? An implement is not something like a goalpost. It's not something that gets passed around from player to player, like a frisbee. Okay, that is not an implement. It's something that individual players would use. All right. So let's actually, what I'd like to do before we start to go through this, these questions, is let's just go through sport by sport and decide which of these uses a ball or an implement. And the implement is used to play with, so you have to do some sort of action with the implement. Okay? Now, badminton. A badminton uses a racket, that's an implement. It also uses a shuttle or a birdie. That is not a ball, so we're not going to put a ball there. Okay? Basketball uses a ball, but it does not use an implement. Cross-country running doesn't use either. Okay? Doesn't use either because people just run, they don't do anything else. Curling. So curling uses these curling stones, so those are not balls. It does use an implement though because it uses brooms. So we're going to put an implement there. Okay. Football uses a ball, although some people argue with me on that one because it's not like spherical, but there you have it. Golf uses both because we've got golf clubs, those are implements, and we've got a golf ball. Okay. Hockey, I'm going to write this down as ice hockey, actually, because there's been confusion with that in the past. Hockey uses just an implement. It's just got the hockey stick because a puck is not a ball. Okay. Lacrosse uses both because we've got the lacrosse net and we've got the, or I actually don't even know what they're called. You guys, some of you who play lacrosse are probably going to laugh at me. But the things that you use to throw the balls with, and there's little nets in them, whatever those are called, plus there's the lacrosse balls. Okay? A rugby uses a ball, a rugby ball, even though, again, that's not really spherical, but go with me. Okay? Cross-country skiing. There are implements in cross-country skiing because those would be the poles. Soccer uses a ball. Softball, there's a bat and a ball, so that's an implement and a ball. Tennis, again, uses both because you've got the racket plus the ball. Ultimate frisbee, neither. Frisbee is not a ball. Volleyball uses a ball, and wrestling uses neither. Okay, so determine the number of sports that require the following types of equipment. So the number of elements in B intersection I. So what does B intersection I mean? Intersection is and, ball and implement. Okay, so we have to look at the ones that use both. And if we count them, we've got golf, lacrosse, softball, and tennis. So that's 1, 2, 3, 4. So this is 4. And you might, in brackets, want to just write, or just off to the side so that you can refer back to it later. Right? What was it? It was golf, lacrosse, softball, and tennis. Okay? Number of elements in B minus I. So B minus I, that's only B. Which ones only use a ball? So if we count up the ones that only use a ball, that's basketball, football, rugby, soccer, volleyball. 1, 2, 3, 4, 5. Right? And again, just so that you can refer back to this, you probably want to write out what that set is. It's basketball, and I'm being lazy, I'm just writing abbreviations, football, rugby, soccer, and volleyball. Okay? Number of elements in B union I. So B union I is B or I, or it could be both. Okay? So anything that's been labeled, basically, right? That's going to be a lot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? 13. So do I want to write this out? Yes, let's go for it. B union I is, let's see, badminton, basketball, curling, football, golf, hockey, lacrosse, rugby, cross-country skiing, soccer, softball, tennis and volleyball. There we go. Okay. The next two are standard of excellence questions. Okay? So the number of elements in B complement or I. Okay? So what does that mean? Not B or I. Not B, can't be B, or it can be I. Okay, now because it's not B or I, if it has an I or and a B, like golf, okay, that is something that we can count because that means that it satisfies the or I part. So even though it's a B, it does satisfy this or I part. Okay, so anything that's not B is anything that doesn't have a B in it, like badminton, cross-country running, curling, golf, hockey, lacrosse, cross-country skiing, ultimate, and wrestling. Okay, so those are all the not Bs. But then, because it could or be an I, we have to look at the ones that have a B and an I and add those ones back in, because those satisfy the or I part. Okay, so this one is tricky, tricky, tricky. Okay, so we're looking basically for not B or I is anything that looks like this. Okay, it could look like this. It could have nothing, because that's not B. It could have an I, or it could have a BI. Any of those are fine, right? Because nothing means it's not B. I means it's or I. BI means it's not B, like that's not okay, but it's the or I part, okay? So any of these three labels are fine. Okay, so if we, actually maybe I'll list those first. Okay, so I'm looking for nothing, I, or BI. Anything that's actually not just a B can go in here. Okay, so actually maybe I'll list those first. Complement union I, right, is anything that doesn't just have a B. So let's see, that's badminton, not basketball because that's just a B, cross-country running, curling, football's just a B, so that's no good, golf, hockey, lacrosse, rugby's no good because that's just a B. Cross-country skiing. Soccer's no good, that's just a B. Softball. tennis, ultimate, and wrestling. Volleyball's no good because that's just a B. So ultimate and wrestling. Okay, so let's see, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's tricky. And then finally, the number of elements in B union I complement. Okay, so if you think of B union I complement, B union I is B and I. Complement is anything that's not B and I. Oh, I'm sorry, my bad. This is not B, this is B or I complement. My bad. So I was thinking of intersection. Sorry, go back. Number of elements in B union I complement. So not B or not I. This is not B or not I. Okay? I was thinking about intersection there. That was my bad. Okay? B union I is everything that has either a B or an I or both in it. Complement means the opposite. Okay, so anything that has nothing. So we're looking for this category, anything that has nothing, neither a ball nor an implement. And if we look at the ones that have no ball or implement, that's just cross-country running, ultimate, and wrestling. Those are the only 3. So this is just 3. And it's, what did I say, cross-country running, ultimate, and wrestling. Those are the 3. All right. So here's one more. Let me just see which ones I'm going to get you guys to do. Yeah, I'm going to do this one as a group on the video, and then maybe I'll get you guys to do the next one yourself. And then if you need to, you can chime in once the video is done to the Google Meet and ask any questions that you may have. Okay, so Jamal surveyed 34 people at his gym. He learned that 16 people do weight training 3 times a week, 21 people do cardio training 3 times a week, and 6 people train fewer than 3 times a week. Determine the following. Okay, so this question is actually quite similar to the one that we did yesterday, except that now the determine the following things, these are all given to us using set theory notation rather than words. The key to solving this problem, though, is to draw a Venn diagram of this situation first. Okay, so you absolutely want to draw a Venn diagram. So we're going to make a big box. And inside the box, we have to have a bubble for weight training and a bubble for cardio. And what we need to know is there overlap, right? So again, just like we did yesterday, we've got these 34 people. And that's our total, so that's what should go into the universe. And then we have to add our number of responses together. So 34 people total, right? Number of responses is 16 people do weight training, plus 21 people do cardio, plus 6 people do neither. And if you add those together, 21 plus 16 is 37, 37 plus 6 is 43. Okay, so we have extra responses. And the number of extra responses is going to be our overlap, right? So our overlap here is the difference, 43 minus 34. And that's 9, I believe, 9. Okay, so if we're going to make our Venn diagram here, there is going to be some overlap. And we've got our weight training bubble, and we've got our cardio bubble, right? We may as well put in the people who do neither, or fewer than, maybe they don't do neither. They train fewer than 3 times a week. So that's 6. If they're at the gym, they're probably doing something. and then 9 people go into the overlap. Okay, and then we can figure out how many people only weight train by knowing that the total of the bubble has to be 16, right? And we've already got 9 people in there. So 9 plus what is 16? The missing number of people is 7. 9 plus 7 is 16. And then similarly, for the only cardio people, we need 21 people in their total because 21 people do cardio, right? So 9 plus 12 is 21. So, or you could just go 21 minus 9 is 12. That's the number of people who have to go in the only cardio bubble. Okay? Now we can start to answer some of these questions. Okay? So this first one, the number of people in W intersection C. Okay? So that's and, the overlap, right? Intersection is the overlap. And this, once you have the Venn diagram there, pretty easy, it's 9. Okay? Number of elements in C minus W. C minus W, we're taking the whole C bubble and we're taking out the W part, that's only 12, right? You can think of that also as only C. Okay? The number of people in C union W, right? That's the or, so we look at either or both. And so that's 7 plus 9 plus 12. And that, I believe, is 28. Okay, the number of people in W minus C, so now we're looking instead of C minus W, W minus C, the only W part, that's 7. Okay, and then the number of people in W union C complement. All right. Well, this is a little tricky. So what I would suggest doing here is let's just pick each of these apart. And what I'm going to do is I'm actually going to draw each one. So if I look at W, that's this part. Okay. And if I look at W union C complement, so W union C means I'm joining these two sets together. But if I take the complement, I'm at the outside. So that's this part. There we go. That's W union C. Now, or sorry, W union C, not with a U, union C complement. Okay, because I'm going on the outside of W union C. Okay, now if this is an OR situation, what you almost want to do is imagine that each of these is on a transparency. And you take this guy and you put it on top of this one. And you imagine everything that's shaded. And everything that's shaded is what you're counting. Okay, so if you were to take this and place it on top of here, this piece would also get colored in. And so if you put them together, right? Well, if you start with this one and you've got that outside part colored in, I'm not doing a very good job coloring, but you guys can bear with me, hopefully. Right? So that's the W union C complement. And then you take this one and you put it on top, the first one, you put it on top as a transparency. Then this part is also going to get colored as well. Okay? Those are all the regions that we want to count. And so basically we're counting everything except for the 12. So when we're adding everything up, what is that? Well, that's the 7, the 9, and the 6. And that is 16, 22. 22 people. Okay? Personally, I find this the easiest way to do it when you're doing an OR. It's almost like draw the sections of the Venn diagram separately and then pretend that they're each transparencies and you're overlaying one on top of the other and imagine what has being shaded, right? That's the part that you're counting. All right. So I think that is the end for today. What I'm going to ask you guys to do for homework is this piece. Okay, and I will catch you guys next time.